Maybe that'll work. That looks like it's working. They pushed out a new Zoom update, and so it changes all the defaults to everything. So it was trying to hook up to a sound driver that doesn't work.
That's it.
All right, so we caught it early though. Any questions on these reactions? More volume, but nothing tricky about it, right?
Yeah.
All right, so let's move on to acid anhydrides. Excessive heat. This only works for acetic anhydride in particular.
Oh my gosh.
Mostly because I think this is just leaning on entropy, the fact that if you're at 800 Celsius, you're making water, you're making a gaseous byproduct. So we can shift ours to
One right there.
yeah. But if we want to do if we want more freedom instead of just being acetic anhydride, plus I mean 800 Celsius is hot, but
Yeah.
especially if we maintain a sustained reaction, but like a Bunsen burner don't get that hot. So you can do it. But the easier way, the more predictable way to do it that works for all acid chlorides is to just expose it to a deprotonated acid. And then that gives us the flexibility to have our R groups be asymmetrical. Because this one only works if you start from acetic acid and you just heat the heck out of it. This works with any R group here and any R group here. And it's pretty easy to find or to store sodium carboxylates in general. Worth noting, this one has to be at basic conditions because you can't have a carboxylic acid acting as a nucleophile if it's already protein. You need that negative charge. All right, and so then the other reactions are going to be really similar. This reaction map. Basically, you can get to the anhydride, you can do the alcoholysis, you can do the aminolysis. Either version, any version of it, you do need that 2-to-1 ratio. The slides are on campus too, that's as PDFs, but always welcome to do that as well. We can do the excess in aluminum hydride to make the primary alcohol. You can do the lithium aluminum trialkoxyhydride to get the aldehyde. You can do the Gilman reagent, or you can do excess Grignard reagent. Really, it reacts pretty much the same as the acid chloride. The trick with the acid anhydrides is because this functional group is symmetrical. If we're trying to go from the acid hydride to one of these other reactions, if it's not a symmetrical acid anhydride, you're going to get a mixture of products. Because you're going to get some of the ester on one side and some of the ester on the other side, unless one of them is a clear-cut better leaving group than the other, which short of having some resonance or something, maybe if it was benzoic acid on one side, that might favor being better leaving group. But you're going to get some sort of statistical distribution of products if you try to do the alcoholysis with an asymmetric acid anhydride. But in general, you don't see asymmetric acid anhydrides that often anyway. They're almost always symmetrical. They tend to just be easier and more predictable to work with them. And I can't hang with this heat today. It is warm in here.
Okay. Oh no. Okay. don't have to go to the gym.
I'm gonna sneeze here in a second, so. There's the logo.
Oh, no.
Yeah. So they also refer to it as the acylation of alcohols in amines, but it's basically the same as that alcohol, so they just use a different term. So acetic anhydride, an alcohol is going to give you the ester. So acetic anhydride again is probably the most common of these because vinegar is really easy and cheap to make. And then it's really easy to just take heat and apply to it to get the acetic anhydride. It's relatively easy to work with. I think it's a solid at room temperature. We have some in the lab. That we use for, you may remember doing the aspirin lab.
We never did that.
You didn't do that even in Gen Chem? Oh, okay. Maybe we'll do that one just for once. Nice lovely crystals and big deal. But basically you just take acetic anhydride and you can add an ester onto any alcohol. That's actually the process of making the aspirin is, so that salicylic acid is looks like this. You expose it to acetic anhydride. This alcohol group is going to react. And you get that, which is aspirin. Right, so in terms of OChem, it doesn't really make sense to do this reaction until we get to this chapter anyway. But maybe if we wind up having, it's a really quick reaction based on what you're used to. You don't even have to get out the OChem glassware. It's mix a couple things and then crystals happen. So now we're trying to make esters. Now we have a couple different ways of doing it. From the acid chloride or from the acetic or from the anhydride, you can make the ester. And these are really easy to make asymmetric. And we do see a lot of asymmetric esters. Where your two R groups are not the same. But because the functional group is not the same, it's not going to be as reactive and not going to be as unpredictable as the asymmetric anhydrides.
Not Williamson.
What's that?
I said Williamson.
Williamson ether synthesis. Fischer esterification. Esterification is exactly what it sounds like to make an ester. The opposite of esterification, the reverse reaction is called saponification. Which that seems like that one's out of nowhere. Except if you know your Latin. That's soap. So saponification is the process of making soap from an ester. You add acid to it, and you break down the ester into carboxylic acids. Works actually pretty analogously to what they do in Fight Club to make the soap. They actually got, yeah, they showed some of that chemistry properly. All right, probably Williamson ether synthesis is probably our most common way to do it if we have the iodides. You have the right methyl iodide or ethyl bromide or something, then this is really easy to do. However, this works really reliably as well. You have the acid chloride. It's a really fast, really high yield way to make an ester. Oh, actually, we just waited for a slide.
Oh, well.
Because there's saponification right there. Also fun bit about a language nerd. I think it's really interesting to trace cognates from base languages. Because sapone means soap in Latin, really close to jabón. which is soap in Spanish. Sort of thing I just always, oh, I see where that came from. It's always kind of fun for me. And now you have to hear about it too. If we start from the ester, just expose it to an acid, especially in water, we're just gonna get the carboxylic acid. Makes a lot of sense, right? Remember that our esters and our acids are both the same level of reactivity because hydroxide and these deprotonated alcohols both make for pretty comparable leaving groups. And then we can make the amide from the esters as well. And then this part down here, reduction and partial reduction of esters is analogous to acid chlorides, except they use diisobutyl aluminum hydride instead of that trialkoxy aluminum hydride. So it's just this divox is what you use to make to do the partial reduction to the aldehyde. But then you still use a Gilman reagent if you want to do a partial, if you want to make the ketone and add in our group, still use a Gilman reagent, that copper lithium. So I'm going to jump back. I'll come back here in a second. So there's a lot of volume in these because there's so many different ways we can go back and forth. That's why this is so important. These two figures keep coming back because, like we keep saying, you can always go downhill. All of them work. It's the same reaction. You go from an acid chloride to an amide, an acid anhydride to an amide, an ester to an amide, a carboxylic acid to an amide. So I know we're going fast and adding lots of volume on these. That's because it's the same thing repeated over and over again. All right. We have practice because when we have this much volume, the best thing for it is practicing. And while you all are working on that, I'll make this a little bit smaller so that we can see everything on the board here. And while you all are working on that, we'll hold this into our break here. We will go till 11, we'll come back. I'm gonna see if there's a different classroom because it's 500 million degrees. Yeah, yes. Okay.
Like, they should really just trust people who work steps.
I know. I don't know why people,
It's fucking stupid.
I can't even, I can't pay attention now.
Like now, we're just wasting a ton of energy. Very good. That was a good question. Oh, my head hurts.
That was a lot of volume, no shit.
I know,
Okay, so what's the first?
It was that big figure that I took a picture of. It makes the ester.
Does it reduce it?
The for A?
Yeah. Trying to.
All the oxidation states stay the same.
Oh,
It's just mixing it basically cuts the acid anhydride in half and like slaps the alcohol and then makes an ester with it.
oh, so you get like 2 equivalents of those?
I guess and something here and probably get the deprotonated carboxylic acid. Yeah.
Alright, so there's nobody in that first T-wing building. Our first T-wing classroom down the hallway here. So we'll just move over there.
Please.
Yeah, we can do that. Let's just do it right now.
I cannot think of this heat making me. Which is not exactly what I want very much. It's.
Just come back for that in a second. Excuse me, sorry. Yeah,
Oh, it's so.
much better.
I've had this. Mushroom before for. With it automatically was going towards my. The table. Oh, sweet, you actually have a.
Little charging station, yeah.
So. You're gonna try to. Chaos, that was right. You know, the whole something. Oh, I know. Yep, it's like.
Oh, that's.
Oh, this one's broken. So it's not.
And this is dumb. Like.
Okay, that's fine.
With the shot, would have been like right by the edge, like that brick doesn't fit.
I know.
Yeah, that's what you do.
Well, whatever.
Well, you plug it in the USB right there.
It's
Oh. It's the trouble with putting technology in classrooms, is it's immediately outdated.
right.
And immediately broken too.
Amazing. Oh, because the word got stumped.
Yeah.
Like that.
I'm not gonna be bent to back if you want.
Oh, let's get stumped. You know.
Once you have to hold this. Yeah, I suppose.
There we go. Not that we needed that, but. Okay.
Alright, well, I got this slide up and then it promptly managed to lock my computer. Recording's still going though.
I love technology.
I know, it's amazing.
I mean, we complain about it a lot, but when I think back to the computers that we learned how to,
Right.
you know. Oregon Trail,
Yeah.
it was a great game. It's not a super like user-friendly experience by today's standards though.
Where or better.
All right, so we'll still come back at 11. I'm gonna go grab my coffee and we'll go over these at 11.
Sweet, that sounds good to me. My brain hurts.
Yep, mine does too. Okay. Okay, B. What are we saying with the? If you've got my.
Yeah. So it's this guy here, or this guy, I guess. So you just keep the carbon.
Well, they basically split, that's kind of what.
Yeah,
I have
so
a hard time with, these fuckers split.
Yeah, they break in half. Think hydrolysis.
Yeah.
It's like basic.
ISIS.
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 Exactly. Okay, I am gonna check my email and do some other shit. What shirt is you? My account that's registered to my account, and that's registered to my account. Plugged in. Yes, we can connect to. Sure.
What was going on there?
Musica. Musica. Very nice and peaceful.
It is. I'm showing if you want to keep it on.
Okay. Um.
Do you have that chart? I could have,
Yeah.
okay.
Here, on top of those things, like, oh yeah, you got that. Like this email.
So did you start looking into that job?
Here, yeah. I should hear back today.
Oh, nice.
It wasn't a hunt date them. But, you basically set like, yeah, you turn in my application. To, for that faculty to HR. And so you do that, tell me, so I did. And he's like, I'll pull it on Tuesday. I'm sure you don't require this little. Tell the dean to hire you. He's like, I can't promise anything because I don't make the hiring decisions.
But I mean,
He's literally.
word of mouth's very good.
I mean, yeah, well, I'm pretty,
Especially here.
pretty.
Damn, week 8 already. Oh, we're doing 2D NMR today, oh geez.
Oh no.
Oh no. Where's this chart? How much shit do we still have to go over? Oh, like 2 more slides. Modification.
Yeah. Oh, I'm so tired. I had fun in Yosemite this weekend.
Oh wow, hell yeah.
Or last week, I guess, not this weekend. I still have to go through. I have so many photos to edit. I took like 2,000 photos.
Jesus.
This guy was getting sendy on a 10C. I climbed on top rope. I climbed this one cleanly. This is called the Bummer. This is 10C, and then this is Lazy Bum. It's a 10D. I fell a couple times. Crux is like up in here. It's bullshit. But it's fun. This was the crack I led.
Jam crack, like 5 steps, cruiser. Like massive cube placements everywhere, just hands, feet. Just freaking awesome. That's the second pitch, 5-9.
That's not too bad.
It's fun. This one gets really vertical down here by the lunge. My feet hurt so bad after 3 days of nothing but crack climbing. I am enjoying OChem, but I am so ready for a break from school.
Yeah, no, me too.
I'm pretty cooked after it's
So I'll enjoy my summer break and then shit's gonna hit the fan.
Yeah,
At Davis.
that'll be good though.
So we'll have to be taking the biochemistry sequence like right out the gate and then PChem. So I have to study calculus during summer.
That sounds horrible,
I only have to take 2 PChem classes though.
Okay.
But still quite torturous.
Not for you, so.
It's the life sciences PChem, so it's like dumbed down. Or well, at least I wouldn't say probably dumbed down, I'd just say it's not as like math intensive. I don't know. We'll see. We'll see when I get there. I'm probably just bullshitting right now. When I get there, I'll speed.
We'll be stoked.
I think I'll be fine. I'm not gonna worry about it too much. But I wouldn't. You know, I'm gonna take my break right now. I can't.
I got through the first stage.
I got through the first thing,
Yeah, I'm taking a break too.
so I'll say that's good enough.
Yep, I concur.
Oh, thank you for being willing to be a reference for me.
Oh, absolutely.
Then,
Yeah, if you, yeah, I think they have to, are you planning to be an adjunct?
yeah,
Yeah, you just need to put down my phone number and just use the college number, so.
cool.
No problem.
Yeah, Nate, this is funny, he's like, can't promise you anything, cause I'm not the one making the hiring decisions. We'll put the application in, let me know when it's in the HR, I'll have them pull it and then I'll tell the dean to
Yeah.
hire you, I'm like, sweet.
Yeah, technically faculty can't supervise other faculty. So we can't even set the. Like the schedule for the department that technically is done by the dean.
Gotcha.
And so,
You're like, hey, this should be
Right,
the
like-
schedule.
right, exactly.
Okay.
But they have final say and everything, including with hiring decisions and who teaches what class.
Makes sense.
So if they decide to force me to go teach somewhere I don't want to teach, I technically have to do it. Yeah, but generally speaking, we
Yeah, I
have a
imagine that.
better relationship than that, so.
Yeah, this, I really like LTCC, it seems just like, for those people who are super chill and.
Yeah, it's nice being in one college district too, because there's some districts, they actually have it. If you have two colleges in the same district, you can get effectively transferred between schools.
Yeah.
Or have to teach at both at the same time. And you know, if you're in the Bay Area or something like that, that could be like a 45-minute commute
Right.
to get to.
Get 3 miles.
Yeah. So it is nice up here that we don't have to deal with that and
Yeah.
that everything's pretty mellow.
Truly.
So I was sitting outside and I saw ATVs going down the trail. I was like, what the hell are those ATVs doing? And I was like, police ATVs.
Hmm.
I know.
Huh.
I was like, I didn't even know they had that. They're probably
You need 'em out here.
for, like homeless people or something.
Yeah, they're probably checking the meadow.
So interesting. I've never seen them.
Yeah, these fun ATVs. That's definitely something I've seen in Amador County.
Yeah.
Nevada, it's big in Nevada because all that empty space.
I believe that. One of my favorite calls that I ever had was we got pulled out to this address and it's like the middle of the night and we like pull up and this is middle of nowhere. And then like this light just coming towards us and it says dude on an ATV. He's like, I'm having some chest pain and like 3 questions in. He's like, oh yeah, I smoked some meth, and he's just throwing some PVCs. And I'm like, oh no, I'm all right, do anything for you at the hospital. You should probably stop smoking meth. Like, if we were taking
Yeah.
down there. He's like, no, I'm not having a heart attack. I'm like, I can see, but I can't promise anything. He's like, all right, I'm good. Gets back on his ATV, rides off into the darkness.
I mean, healthcare professionals, right? You're supposed to trust your healthcare professionals. We don't have any markers in here, so I'm gonna grab some markers so that I can draw on the whiteboard over there. Seems like there's some markers in here.
Right. I was looking at reports.
Crackheads are hilarious.
And probably just paranoia, chest pain, honestly, dude, is probably.
But no, he was throwing PVCs. So he was having premature beats
Oh.
in there pretty frequently. I mean, he smoked meth, he was like 70, smoked meth for a while, his heart's tired.
Tired, it's done.
Tired.
Yeah. Yeah.
I'm gonna work overtime for no reason. Kind of like me on the ambulance. Sipping shit. But totally forgot what happens when you reduce an enter with lithium aluminum hydride.
Well, it's excess, right? So it should.
So when does it go?
Does it just like go through the whole thing? For sure. Yeah, it does.
Like what? So what does it make? Like a diol? Or does it the OME bump off and it makes like
Which one?
for A from the second set and bottom set? Does it make like methanol?
I think
and-
the OME fucking pops off.
I think so. That makes
Right?
that seems
So
right.
sit would have to fully reduce, so
Otherwise,
they'll
yeah.
just turn into an aldehyde and then. Yeah, you're left with methanol, maybe.
Yeah. That's what I'm going with. That seems right to me.
Um, yeah. And the same thing I would imagine with B, except that you're deciding nothing to it
Yeah.
instead of the aldehyde. I'm just gonna do these in my head because I'm not in the mood to write them down. I just can't right now.
Remember what? This is really bad ones. They're mostly because just want to have this for review.
Right, yeah.
I'm so pressed for time right now. I really want to be lazy, I just can't.
Yeah, yeah, yeah.
This would be about it.
Sorry, I got sidetracked.
It's all good.
Alright, so for A, for the first A. So we got benzoic anhydride. We're gonna make the ester out of it. So it'll be phenyl benzoate would be our product. Anything with nitrogen, gonna make an amide. Yep. So we're gonna take the propanoic anhydride and react it to make the NN diethyl propanoate. So propanoamide. Propanamide, that's the word.
You just have to remember with these reactions that it's splitting.
Yeah. Yeah, the anhydride looks the most unique out of them, but it's
Mhm.
really the same thing once you remember that this whole thing is the leaving group.
Right.
So C is a complicated molecule, but it's the same process.
It's just gonna be the alcohol that's gonna be real.
Mm-hmm. And then we're gonna get this secondary amide again over here. So for D, we'll get. All right, and then down at the bottom is all the reduction reactions. So complete reduction, so we'll get all the way down to isopropyl alcohol. Ooh.
Uh-oh.
We're just gonna do that.
We'll push it to the side.
I'm gonna try to see the comments. I'll go get some whiteboard cleaner when we're done here. Same molecule, excess ethyl magnesium bromide, add to ethyl, so the tertiary alcohol. This one's a little bit interesting because we do wind up with a ring opening reaction happening. So we should get 1, 2, 3, 4, 5. So 1, 5. 1, 5 pentane diol as our product. And then ether synthesis, deprotonate, act as a nucleophile. So we're going to make the ethyl benzoate. And then another ring opening reaction. So we should wind up with 2 ethyl groups added here. This one's definitely one worth drawing out.
And with the Grignard reagents, because it's excess, you're gonna be getting 2 of those.
Yeah, we're gonna add the ethyl on twice. To the top one, this, and then this bottom one, 1, 2. So we'll get. I don't even wanna name this. That doesn't, that's not a fun one to name.
No.
Call it. Yeah, no, I'm not even gonna do it.
The please no diol.
Yeah, exactly. Maybe we'll just build it in Moldio and see what Moldio tells us in a few minutes. All right. So if we're trying to make amides, we have the most ways to make them. Hydrolysis of or acid chlorides are gonna give us the best yields. Which makes sense, it's the most downhill in energy, right? So equilibrium is gonna favor making the amide most strongly. However, once you make the amides, you can convert back to the carboxylic acid with acid and heat. Basically that's just leaning on Le Chatelier's principle. There's gonna be enough. If we have a high enough concentration of the acid of the water, then concentrations are just gonna drive us towards the products. And especially as ammonium deprotonated is ammonia, obviously, right? And that's a gas at room temperature, so it's pretty easy to drive off the ammonia and cause the reaction to go that way. So that is notable in that it's one of our uphill or upstream reactions. So we can go from an amide to a carboxylic acid, and then we could go from a carboxylic acid all the way back to the acid chloride. And then that opens everything up.
Now, what was the thio? Was that
Thionyl chloride,
thionyl? Chloride?
Yeah.
Okay.
that SOCl2
Yeah.
is the reagent. For the for taking the acid and getting it to the acid chloride.
Oh, yeah.
And then the reduction goes a little bit differently. If it's an amide, if we expose it to excess lithium aluminum hydride, instead of reducing the carbon and the oxygen here, the oxygen's a better leaving group than the nitrogen is. So you wind up making primary amine instead of making primary alcohol, which then opens up a whole wide range of reactions as well, that we'll get to in all likelihood. Amines really start becoming more interesting once you get into the biochem, because all the neurotransmitters are amines. And so it's really, really important in terms of medication and in terms of neurology, neuroscience to work with amines. So you see that a lot in biochem. So if we don't get to it now, you'll see it soon. All right, so there's more practice here. And again, I think. The PowerPoint slide is working, but nothing else on my computer. And Zoom is working, but not responding.
Gotta love it.
And I guess I didn't check. I can't check now. On whether the audio was working after we switched rooms. So. might be a, this recording may be of questionable value.
Zeke.
No, I have not. And one of the things that I will also link, I was gonna throw it up on the screen. But technology is there's a really good reaction map from the website Compound Chemistry, where they basically they take all the different functional groups and make them like stops on a subway. So it's arranged graphically. So it gives you a, okay, I'm trying to get here and I'm starting over here. How do I get there? Well, I can take this route or I can take that route.
Helps with synthesis.
Helps with synthesis a lot. Some of the specifics and the conditions they recommend are a little bit different than what our textbook does because well, it shouldn't matter, but the dude is in the UK and so they have different, I don't know if culture is the right word. But standards, I guess. They still use molarity and everything, obviously, but they just have like, okay, you do it this way. It's just a little bit slightly different culture for some of their reactions. So it might look a little bit different than what we would have written, but it's the same gist. And still, if you can remind yourself and plan out how to get from functional group to functional group.
I don't know if I trust people that eat beans for breakfast though.
Full English breakfast, tomatoes.
Tomatoes, beans.
And a Guinness. I did have that one time. I was super hungover and flew into London and it was like 9 a.m. We pretty much stayed up all night and then went to a little pub and had like the classic English breakfast with the eggs and the beans and the
I
sausage.
mean, you get why, like that's the situation for which it was invented.
It was great.
It's not a totally spectacular breakfast, but it might make you feel a little bit better.
It's the spot.
Yeah,
in certain situations. This was back in college.
So how do we do this one? This one's a bit of a review. It's a good synthesis problem there.
Trying to remember.
So that's a fairly specific functional group there, right?
Right, yeah.
That one showed up. That was one of the ways we could do a protecting group on an aldehyde. Right? Or on a ketone. So if we can get from, so if we just use ethylene glycol to react with the aldehyde, that adds this piece to the aldehyde. So we just need to get benzoic acid to benzaldehyde, which we can do with, make sure I don't mix them up. We want to use the lithium aluminum trialkoxyhydride. So we take benzoic acid, react it with LiAlOR3H. That's going to give us the aldehyde. That's the one that gives us the selective reduction. And then. So what is that, ethylene glycol,
Acetal.
acetal formation, yeah. F might be the trickier one here.
Yeah.
I could think of a way to go from this to that,
Right,
Yeah.
yeah.
but not going the other way around. We're gonna have to do something to chop off all those extra carbons, right?
Yeah.
So when we want to remove carbons. There's one reaction in particular that winds up being helpful. It's our ozonolysis.
Yes.
So for this one, if we can put a double bond right here, that would be ideal, but we can't put a double bond there because that's a quaternary carbon.
That's a head scratcher.
We could put a double bond here.
Yeah.
And then chop everything off and then add one more carbon back.
Yeah.
It's like
So we
elimination.
yeah, we do an elimination. We do the dehydration. Which we can do with just strong base and heat, right?
Yep.
And that's one of those other ones too that we might have a specific reaction. Because it's a benzyl, we're making a conjugated double bond, there might be a specific reaction for it. But once we get here, even without going back to look anything up. Then we can do ozonolysis. So O3 followed by DMS. Gets us the aldehyde. Is this pathway gonna work? Is that gonna take us where we wanna go? Gonna add one more methyl on there pretty easily, but how, we're gonna have to do something about shifting where that oxygen is.
Right. Yeah.
And considering we already started with the oxygen in the right spot here. Maybe we're going through the wrong rabbit hole here. So we could make that a ketone.
How do you get rid of the TU?
How do we get rid of the T-butyl?
Because there's no way to convert that into a good leaving group.
Right, I mean, it's quaternary, you can't.
Yeah.
So you might want to go back to your notes from last quarter. We're gonna end lecture here. I'm gonna give you the rest of the time. To work on this, check your notes, because this one is a tricky one.
Yeah.
right? So we kind of looked at some of the more obvious pathways. Might go back and double check any other reactions we have for modifying the carbon skeleton. And see what we can do.
Okay.
And then we'll go over at the beginning of lab. The lab we're gonna talk about, we'll start with a short. Short lecture-ish introduction to 2D NMR. And then I'm just gonna turn you loose on with a bunch of spectra. And a packet to work on. For the most part, I don't, the 2D NMR, the way we're gonna approach it is not gonna be. Here's an unknown, what is it? It's more like, okay, you know what the compound is. Assign all these peaks to the right hydrogens and carbons. So it's a little, it's because it is still pretty abstract once you get into the 2D NMR. So a good place to start is with a known to try and start interpreting it. All right. See if I can. Now it's working. It is, okay, and the audio is working too, so.
Sweet.